All right, I'm going to share my screen also. All right, can you guys see my screen? Yes. All right, cool. So we had a few challenges yesterday. I definitely want to go over some pairs because I do have some talking points there. I'll let, since I was talking to Sean earlier, I'll let Sean pick. Sean, would you want to see Armstrong numbers, credit check, or anagrams 1 as a challenge we go through? I think you're muted.
I would like to see credit check.
Credit check. That's a great one. Nice algorithm in there. So great choice there. All right, so I'm gonna pop that up, and actually we're gonna do things slightly a little differently today. But let me fork this over. Fork that over. Oops, looks like I already forked it over. So, oh yeah, I did that yesterday as my example. So let me copy that down. Git clone. Hopefully you guys are familiar with this process by now. So we clone it down. Then I'm gonna open that directory. And open up a coding window. Sorry, one moment. Let me make my screen brighter in case it's too dim. All right, I'll do that later. Can you guys see my screen? Is it too dark or dark? Okay, so open that up. Let me move that to a new window. If you guys don't use virtual desktops on Macs or I think Windows 7, I would highly recommend them because I usually have like 20 windows open, get to have extra workspaces. But okay, so what are we doing here? Oops. All right, let's read the README. So I'm going to do this one, or we're going to focus on Python for this one, and then we'll do JavaScript for one of the other challenges, just to kind of have exposure to both. So there's something called the LUN algorithm. It's for checking sum. You guys can read more about it. Hopefully you guys kind of get some nice background from the Wikipedia page. I'm not going to spend time talking about that too much, but it's just a way to kind of validate that you have legit credit card numbers. So they kind of give you an example down here. The way it works is from the rightmost digits, which is, actually move left. All right, so there's a bit to it. With the product doubling operations random 9. Take the sum of all digits if and only if. Okay, so yeah, there's a number of steps to it. We'll kind of get to that when we're pseudocoding or writing our solution. But let's actually focus on the testing portion first, because again, test-driven development or test should drive first. So let me open up Python. So we have 2 files. We have the spec file, which is where our test cases should be, and we have our main file, which is where your solution should go. So first, I'm going to go to my spec file, and let's write some test cases. So the primitive way, the way we kind of started doing it was usually with print statements or console logs, and kind of just checking that we have our expected value and our expected output are the same. But yeah, so this works, but writing test cases and have a unit test is a little more robust. So that's what we're going to convert these primitive test cases into the unit test framework for Python. All right, so the first thing I need to do, if I want to use unit tests, that's a library that automatically comes with Python, but something that I need to import. It's not automatically available for me. So I'm going to import unit test. All right. Now that we import a unit test, we want to start using it. So let's get that up here. All right, so we need to add this line. And I know this kind of seems like a kind of random line. We haven't talked too much about it. You can kind of just accept it that it's something that's needed. What it's actually doing is checking to make sure that this is the main module that's running. And if it is, then only then is it going to load the unit test or initialize the unit test library. So main, it's all right. So again, this is required. You don't need to know too much about it. Just remember you need to add that in for unit tests. All right. So we imported. We got that initialization done. Now let's actually write our class or test case class. So we haven't talked about classes too much. Don't worry if you're still kind of like, what's a class? At this point, we're just saying accept the syntax. We will get to classes in depth next week. So I'm going to create classes. Let's say credit check. And remember in Python, even though we use snake case pretty much for everything, classes, for whatever reason, whoever agreed upon the syntax or the formatting for, the style guide for Python, they said camel case for classes. So we're going to adhere to that. And then we're going to write unit tests dot test case. getting slightly ahead of ourselves, but what this is actually doing is basically taking this class. So test case is another class that exists within the unit test library. And we're actually taking all the good stuff that test case gives to us, and then we're extending it with our own class. So basically we're getting a bunch of functionality from this test case class. And actually, if you want to maybe dive into it, I'm right clicking here and going to definition. This is what the test case class is. So this is not a file I wrote. This is case.py. This is something in the Python library. So again, just to review what I did, I control clicked, and then there's an option to go to definition. It looks like an F12 with the shortcut. That lets you kind of inspect what you're actually working with. So test case here is another class that inherits from object. We don't have to worry about object. But again, there's a ton of stuff in here. Again, you're not going to know most of what's going on in this class because we haven't talked about classes, but there's methods in here. There's variables. There's a lot of functionality baked in. So if you're curious, you could dive into it. For the most part, you don't need to bother diving into that level of code. But anyway, we're getting a lot of stuff from here, and we're just kind of extending and adding some things on top of it. All right, so we're creating a class with the class keyword, and then we're going to write some methods. These methods are what our test cases are actually going to be. So let's write a test case. I'm going to slow it down. All right, so it looks like we have a test case here that's checking to see that a number is valid according to the Lund algorithm. So let's say test is valid, put a 1 on there because we might have multiple, and then self keyword. Again, the self keyword might seem kind of odd, something we'll cover next week for sure. But just know that you have to have the self keyword here. All right, so that's a parameter that's we can use. We're going to call assert equal. So as Tom mentioned yesterday, there's a whole list of functions we have access to. Obviously, we did not go through every single one of these functions and tell you what they do. For the most part, hopefully their name kind of tells you what they're going to do. Like if I just pick random one, assert not regex, I assume that checks that something is not a regex value. Assert not in, I would assume that's going to check something is not in a data structure. But anyway, so yeah, the name should kind of lead you to what they actually do. But the key here is reading documentation. So again, we're not going to go through all these functions, but they are documented on the web. So if you're curious, like, hey, what is assert is instance? What does that function do? You could definitely research it and kind of learn more about it. So that's, again, being a developer is reading documentation. There's no way around it. All right, so I'm going to use assert equal. So let's use that function. And now what do I want to do? So this is what we're comparing against. So I'm going to put that on one side and then credit check for the other side. So again, what this function is doing is going to take in 2 inputs and make sure they're equal. If they are equal, then the test case will pass. If they're not equal, the test case will fail. Any questions on what we've done so far about setting up our unit test framework? Okay, so that's one test case. Let's kind of just add all the ones they had for us, and we can maybe add some extras. Do this a little quickly. So we have test case 2, test case is valid 3. I'm going to copy these in. Okay, so those are those 3 test cases. Then we have a couple test cases checking is not valid. So again, when you're writing test cases, make sure you cover every general case. Again, you're not going to be able to cover obviously every iteration, right? Like how many iterations of these numbers can you have? Variations, like I'm not testing, 5 billion code combinations, but you want to test, some numbers that are valid, make sure that the output is correct, some numbers that are invalid, maybe some other fringe cases, like maybe your data types, make sure you get the same correct data type, as in we're returning a string from this function, make sure you get a string returned. And any other like edge cases generally get to test if you can think of them. So is invalid 1 self, and again, that self, it's kind of a magical keyword at this point, but kind of just understand that that's how we access these methods. Not valid. Assert not equal. Oh, sorry, we want assert equal still, because we are still comparing against the output, which is numbers invalid. Okay, that looks good. As I'm copying and pasting and hopefully doing this correctly, any questions, please ask. Okay, so that should be our main 6 test cases that we kind of converted from just print statements to being actual test cases. So we have 6 of them. Let's add a couple other test cases. So as I mentioned, I think checking type.
Yeah, Ankur.
Yep.
Can you explain why we're not doing assert not equal, even though the test cases are the same? Like the inputs are the same?
Oh, you mean for these versus the valid ones?
Right.
Yep, no, great question. So the reason I'm still doing assert equals is because we're checking against a different output. So our function is expected to output is valid or is invalid. So we still want the return value of this to be equal to this, because it should say number is invalid.
All right, got it.
Yeah, but yeah, initially I was writing not equals, and so we could write a test case. Actually, I'm going to change it. So I'm going to change this to not equals. Hopefully it doesn't confuse anyone. I'm going to change this to is valid. So normally, if it is valid, we should get the number is valid. But I'm going to make this test case a little special and checking that the output of this should not be this, right? So this is now saying valid, and that should be not equal because this number should not be valid. So yeah, I'm going to change another one too. I'll change this one. And let's say this one should not equal the number is invalid because the number is valid and the output should be the number is valid. So yeah, you can kind of vary it that way. Yeah, so equal, okay, test is return string, because we expect to return a string. If we return something else, that's not a good sign. So assert equal, and then there's in Python, there's a function called type. So we can just check the type. I'm just going to reuse one of these examples, and I think str. Yep, that's class. All right, so type should be str. Those should be equal. Can anyone else think of edge case or some other test case that we should maybe consider that might be good to kind of add in? I'm trying to think if there's anything
Maybe the
else.
type of the output or something. Oh no.
Yeah, you know, if we think of something else, we can maybe add it. Can spend maybe a few more seconds.
String length.
String length. I guess string length, again, we're putting out a string that's like English, as in like an English sentence. So there's no guaranteed
you're right.
string length. I mean, we get to check the input, but that'd be something the function does for us. Or should be for
Is the function supposed to check that it's a valid size or something like that? Is there functionality of the function that it's supposed to check that we could check? I don't know if that makes sense.
Sure. Let's actually, yeah. I don't know. I don't think this was a requirement, but let's actually make it a requirement now. So whenever we solve it, let's say test checks inputs length. So let's I don't know how many digits this is. 16 digits. So let's say, for example, if we only had like 8 digits, 1, 2, 3, 4, 5, 6, 7, 8. That should be an error. So let's say, again, we're adding functionality here. Obviously, we could do more if you want, but let's just say that should equal invalid input. Okay, so that should be the return value in that case. Actually, I'm going to jazz this up a little bit. Actually, no, we'll keep it simple. So assert equal, that's a bad number, invalid input. Okay, cool. So those are our test cases. Great. Let's run our test cases right now and see what happens. I assume we're going to fail all of them because
You got an extra close parentheses there.
Thank you. Yeah, I assume we will fail all of our test cases, but let's see our baseline and then try to improve upon it. So to run this, I'm going to do Python credit. Oops, I'm actually going to do this.
Type in that last line as well.
What was that?
Line 27, type.
Type. Oh, yes. Good eyes. Good eyes. Yep. Okay. I'm going to run this and oh no, I got an error. Let's see, I'm gonna call on someone. Let's see. Who we have that? Brian Slusher, can you maybe help me out here? I got this error. I'm not sure what's going on here. So what is the error telling me?
Yeah, the error is saying that there is no such file.
Okay. So why might that be?
Maybe you haven't saved it.
Good guess. No, I have saved it, so I have the auto save on. So again, part of being a software developer, we gotta get familiar with reading error messages. Not the easiest to read when it's kind of like wrapping like this. But yeah, the first thing is I notice I get an error, no such file directory. So that kind of alerts me like this file definitely exists, right? So that's not the issue. But then I want to look at the file path. So it's trying to look in users code Platoon, which is my computer name, code Papa challenges. I'll go credit check. That's our folder we're in, and it's looking for credit check spec. So the issue here is it's not, the file is not on this level. We need to go into our Python folder. Again, easy mistake to make. I've made it many times. So I kind of want to just slide that in there. But to resolve that, we could do Python and go Python folder and then credit check spec. There we go. All right, so I'm just navigating into the folder to run that file, or sorry, I'm running a file with the folder name appended, or I could go into that folder. All right, so notice we ran 8 tests. I assume we failed them all. Oh no, we actually passed a couple. How do we pass them? Oh, all right. So this is a case of a kind of a false positive maybe. We changed a couple test cases to be not equal. So credit check is returning something, which is a value of none, because if you look at my credit check file, there's nothing. This pass statement just means there's nothing happening here. So the default return value here is going to be none. Therefore, when we compare none to this string, they are actually going to be not equal. So maybe again, this isn't the best test case, but it still catches some errors if we were to return something that if we accidentally return the number is valid, for example. Was there a question?
Yeah, so I'm following along and I got the results, right? It gives me all the falses, which it should. But the thing that's odd is, you have like your full-blown report, which is what we were getting yesterday, whereas I literally only have falses. Is there something that like I mistyped or like an extra thing I'm supposed to include to get that full report?
Yeah, I'm not sure offhand, so might have to take that offline. Make sure you're not running any other flags. So you could set some flags here, like there's something called fail fast, which will only run until it encounters one failure and it'll stop automatically. I doubt you're adding some parameters there, but that'd be my first guess, but I'm not quite sure, honestly. If someone else happens to know, they could maybe chime in there, but yeah, so again, we failed 6 out of 8 test cases. Again, we passed some accidentally, but let's try to pass them all now. So in the interest of time, and also in the interest of getting a little more interaction here, I'm actually going to check some of our pull requests. So let's go to pull requests. We've got 9 pull requests. I was hoping for a little bit more. Let's see, who do I want to hear from? Let's go to Kana. So I'm going to go to Kana's directory. I'm going to Python credit check pi, and I'm going to copy down her solution. So I'll copy it this way. And I'm going to paste that into my solution. So again, normally you don't want to just take someone else's solution, but we're going to be expediting it a bit. So Kana, I'm going to put you a bit on the spot. Can you help us? Can you kind of walk us through this code? Looks like I have an indentation error.
Sure. So what I did was I first created, okay, so the first thing I wanted to do is take the string and take out all the different digits. So that's what I did in my first 2 steps, is to initialize an empty list,
Okay.
and then set the numbers to, or within that list, I put all the numbers into their own index, essentially.
Yep, so just one, line 8. So notice she's actually taking the string. It's actually a string, and you're able to do a for loop through it. So Again, as I mentioned, strings can more or less be treated just like arrays and lists. So you can iterate through each character in that string. So this for loop is basically extracting, let's get a sample output or input. So let me grab this one. Yeah, so if this is our input, it's going to go through, grab the 6 as a character, meaning it's a string, then a 0, then a 1, and it's going to check all those. And it looks like, as kind of said, she's grabbing the character, converting it to an integer. Because again, when you're iterating through these are all string values. Each character is a string. Converting it to an int, she gets a number, so that's not a numeric data type, not a string data type. And then she's appending it into her digits array. I see you added a semicolon. I assume that was a JavaScript,
Yes.
JavaScript thing. Yeah, it doesn't hurt us. I think Python will still compile with it. But yeah, okay. So great. Yeah, so we basically go through the string, get each of those digits, convert them to numeric values, and store them in digits. All right, great. That sounds like a good approach. All right, so
then,
go for it.
So then after that, you would have a array digits or a list digits that had 16 indices. And so now you're gonna go through and for the for I in range 0, 16 to 2, you're going every other, starting from the first digit, and then you multiply the digits bracket I, multiply each of those digits by 2, and it'll be saved back into that list index as the new number. And then for if you go to line 19, in this case, I'm checking for if I'm still within the for loop. So now I'm checking each index to see whether the number is greater than 10, which means it would have 2 digits. In which case, if that statement is true, then I will just subtract 9, because you will never have more than 18. 18 can be the biggest number because 9 times 2 is 18. So instead of doing anything else, I just subtract 9.
Okay, so yeah, just going out the README. So that, yeah, this is Rakana's checking if the product of doubling operation is greater than 9. The sum of digits is then, then sum the digits of the product. So 10 would become 1 because you sum up 1 and 0. 14 would be 5. All right. So is this a shortcut that you're doing for summing up the digits?
Yeah, it's shortcut simply because we know that it will never be more than, since we know that, and maybe this is, should I write a comment about this if I do something like that?
Yeah.
Since we know that the biggest number that is possible is 18, you know that to add the digits, if it is a 2-digit number, you're just adding 1 to whatever the second number is. So
that's actually really smart. Yeah.
Yeah, it's really like digits bracket plus 10 minus 1. And so or minus 10 plus 1. And so I just said minus 9.
Gotcha. That's actually really clever. I actually never thought of that, but you're right. If the max number is going to be less than 20, and if it's 2 digits, you know the leading digit is going to be a 1, so you can subtract 9 and get the same sum. But yeah, the thing you mentioned, definitely if you're doing something kind of like clever like that, as a coder, definitely add a comment to say, hey, we're actually trying to add the numbers, but this will accomplish the same thing. Because like me looking at it or any coder looking at it, I don't think it's inherently apparent that this will give you the sum of individual digits. But yeah, so yeah, definitely add comments if you're doing something that's out of the ordinary. And that goes for everyone, not picking on Kana here. But no, it's a clever way to do it. Yeah, I never thought of it that way. So again, we said this before, there's multiple ways to solve the problem. I like this, that cleverness right here. So yes, this line 20, is actually giving you the sum of digits. So if you have 14, that's a 1 plus 4, which coincidentally enough is the same as 14 minus 9, which gives you 5 also. Cool. All right, that's a neat little trick. So that sums up multiplies the digits and then gives us a sum. All right, cool.
So now we are adding the digits in. The next step is to add all the digits in the list. So
Okay.
I will again do a for loop in which I take each digit and add it to the variable sum. And so that is why sum is outside my for loop. So it's initialized as 0 and then it counts up based on each index.
Yep, and just,
I see.
let's just kind of break this down a little bit more in case anyone is having some trouble following. So digits is going to contain something like, so if we started with this input, digits will actually be an array. It's going to have 6, 0, 1, 1, right? It's just stripping off each of these and putting them into individual indices within this array. So we have 6, 0, 1, 1. I'm not going to write all of them out. Eventually it'll end on 2 and 8. Right, so again, this dot 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 is not valid syntax, but it just illustrates we're breaking apart the string into digits. That's what the digits array contains. Eventually, we modify the digits in place. So basically, we take this and then we're going to convert it. So let's kind of do this by hand. This for loop up here is going to convert it to. So if we do this kind of mentally, 6 we multiply by 2, and then we get 12, and then the sum of the digits for 12 is 1 and 2, so you get 3. And again, kind of as a little trick here is if you have 12 subtract 9, you also get 3. Then we skip to the third digit, right? So
Well, you would still put a 0 there, because at the end of that for loop, you should still have 16. So that would be 0.
gotcha.
And then
Yeah, you're
once
right.
you get,
So,
then for the, sorry,
oh no, you're good. Good. Go for it.
that's exactly, yeah, for the third index, it would be 2, 1, and then the last 2. The 8 would be the one that you don't touch. So 2 times 2 is 4.
Yep. Yeah. So again, you guys can work it out if you guys are still trying to do this at home, but eventually your digits array will look something like this. So originally it was this, and Kana is basically using it in place. What we mean by that is she had an initial array and she's updating values in there. An alternative approach, which isn't wrong, is you can create a brand new array. Like I could say something like doubled digits. Not that every digit is doubled, but you create a new array. And instead of updating that original array, I could update double digits and just append a new value. But I guess that would not work for the right. Anyway, I'm not going to go down that track, but anyway, cool. So we got that far, and then Kana was telling us she's summing up the digits. So basically, she's going to go over this array with modified digits, sum them up. I'm not sure what the sum of this is, so or whatever that would be. So I'm not going to compute that. But we get some single value. So some, let's just say, some might be.
It was
make it up.
70.
70. All right. Okay, cool. And then what's the last thing you're doing here?
And then, so what you're checking for is the mod. It's so essentially the mod is there a remainder if you divide by 10?
Mhm.
And so here I'm just checking for if there is a remainder. So if sum modulus 10 is 0, then that means that it goes into the mod perfectly and it is a valid credit card number. So I just return the number is valid. And if it's not valid, then it's invalid. So I return it's invalid.
Absolutely. All right, excellent. Kana, I think this is a great solution. One, definitely want to compliment Kana writing comments. And that's not something we've mandated, but it's always good to have clear comments to kind of guide anyone else reading your code. Every few sections, like every chunk of code should have a comment, even if it's obvious what you're doing, just kind of like visually. So like if I'm looking at this code, I can kind of easily see, all right, I'm in this piece of code. I know exactly what this block of code is doing without actually having to parse it, parse the code myself. So excellent format, commenting, highly recommended. Hopefully you guys are commenting your code. I know that's something that you guys aren't focused on right now. You guys are focusing on solving problems and kind of getting through challenges, but commenting, a great skill or a great thing to add to your code. All right, Kana, thanks so much for walking us through your code, and thanks for letting me borrow it. All right, so this is kind of solution. We wrote test cases earlier. Let's run our test cases and see what happens, and then we could go from there. So bring up my terminal, which is Control tilde. I'm going to go into my Python directory, and then I'm going to run Python credits check spec.py. All right, so notice we ran 8 tests. We failed 1. I know why we failed 1. It's nothing to do with Kana. Kana, your solution's fine. The reason we failed it is because we added a new test case where we want to actually check the input. So obviously that wasn't a requirement, so Kana would have no idea to do that. But since we added this in, let's kind of modify Kana solution, which should be pretty straightforward. So string we need that to be 16 digits, right? Otherwise this algorithm won't quite work. You know, we have, 16 here, we're expecting 16 digits. It's always good to kind of verify that. Obviously that should be part of your requirements in terms of if you're handing this function off to someone, you should say, hey, your string needs to be 16 characters exactly. So if len string not equals 16, we just return invalid. Okay. Right, nothing too complicated there, but yeah, Kana had a great solution. Any questions about Kana's algorithm? Anyone have any questions about any of the code that we went through? Please do ask.
Colon.
Yes, thank you. I don't need parentheses, it's Python. Again, those parentheses are optional, but I usually always add them just for JavaScript. Invalid inputs, I think that's what we want. All right, let's run our test cases, cross our fingers, hopefully we pass them all. Awesome, all right, 8 test cases, we passed them all. So again, the approach for test-driven development, create your test cases first. Don't try to create your test cases after the fact, because again, you won't be really focused on what you're trying to achieve. You're trying to, you code up your solution and then you might try checking it. That's not, again, that's not wrong. That's just against the test-driven development policy. Okay, any other questions about credit check? Did you guys enjoy learning about the London algorithm and trying to implement it? Was it difficult, straightforward, just kind of walking step by step, going through the London algorithm, which are all these things?
Just a quick. Go ahead, Mike. Thanks. I noticed that, Ankur, you wrote several tests before you ran the tests. Is that normal, or do you start with just like, is it easier just to do like one test at a time, make sure that test passes and then kind of do the next test? But I'm just curious.
That's an excellent question. I think there's cases for both. I think if you're creating your algorithm, you might want to, especially if it's like a larger project. So let's go to project scope, like instead of just like one algorithm. Yeah, if you're creating a project, you're probably not going to write the entire project just one time and then test it. You want to incrementally test it. So you might write a piece of that project, write some test cases for it, verify that it does exactly what it needs to before moving on to adding on to that project. So I can see cases for both. I think it just depends on your scope and maybe your methodology. So like I'm not the testing expert. So again, you might find it better to kind of implement one function, test it. In this case, again, we only have one function. But if we're creating like multiple functions, it might be good to write one of those functions, test it, and then add on with multiple functions or test cases for other functions. But yeah, that's probably the way to go. Yeah, I'd say again, the more pieces you have, test each piece along the way. That's the whole idea of unit testing. Test the units, don't test the whole thing all at once.
Ankur, correct me if I'm wrong, but as I understand it, the idea is to write tests because you're coming up with requirements of the code that you're about to build the functionality for. So you write the test to test that it does the things that I need it to do. And then when you get there, you can test all of it. Is that the idea?
Yeah, I think that's well put. Yeah, you want to take your requirements and create tests from that. You don't want to jump into coding. Again, this is the test-driven development methodology. It's just one methodology that exists out there. There's if you guys did your reading from yesterday, if I can find that quickly. I think they had an article about test-driven development versus behavior-driven development. So again, there's other methodologies out there. You guys can hopefully read those if you guys are curious. Okay, cool. That was a great solution. We did our test cases. We ran our solution. Thank you to Kana for being put on the spot and explaining her solution, but great job. All right, any other questions about credit check? About unit testing, about the algorithm, anything? All right, well, hope you guys enjoyed that challenge when you guys attempted it. If you didn't get to it, hopefully you guys could go back to it and try to solve it yourselves. All right, so I'm gonna stop